Good morning, good afternoon, and good evening, everyone. Thank you for joining today's webinar on cnHeat. Today we have Seth Poche and Dan Sullivan talking to us more about providing coverage to customers. Dan, Seth, you can take it from here.
Hi, everybody. My name is Dan Sullivan, and I work with Seth Poche on cnHeat. And we're here today to share with you a feature that we're releasing at the end of the month. It's part of cnHeat Locator, the heat maps, and we call it minimum SM height. And basically, what we believe is a substantial improvement that if you have a signal that's within 80 feet of the ground or on top of any location or home, if the signal can arrive there, we can tell you how to install that customer and install them at the optimal height. And what we believe is that this is something that you can train your customer service representative to do with anybody who calls them on the phone. Within like a couple of minutes, they can tell them exactly how the install will be and how it can be minimized and optimized, and you can reach many more customers than you can without cnHeat, or an only improvement on the current cnHeat for the couple of layers that you have today. So words are great, but pictures and a demonstration are much more important. So I'm going to turn it over to the brains of the operation, Seth Poche, and he's going to go through and give you an example of a demonstration of what minimum SM height is for cnHeat Locate. All right, Seth.
Awesome, thanks, Dan. I'm assuming you can see my screen?
I see your screen.
Okay, good enough. All right, so I guess the first question is, why is this new feature so interesting? And to answer that, you have to understand, some of the previous limitations of cnHeat. Previously, we would provide two different kind of slices, two different layers when you looked at a prediction. So when we'd run a prediction for a tower, we'd provide what equated to a minimum height that an operator would be willing to use, and then we'd also provide a maximum height. And from that minimum height and the maximum height, the operator could, at that point, derive whether or not they'd be able to install at a given point. But there's some limitations there, so if you want to run, minimum height of 1 foot, like above the roof line, and then maximum height maybe 10 feet, what happens if you want to go and put a tower in a yard somewhere where you might be willing to build a 40-foot tower or 50-foot tower? What happens if you find a particular customer who's willing to go above 10 feet for their house? They're very interested in getting connectivity, or maybe they're, a ham operator. They already have a mast going up beside their house well above 10 feet. These are some of the things that we're struggling with customers. A lot of customers would come back and say, we really want more than just 2 layers. We need 3, or we need 4, we need 5. And so we feel like with this new feature, we have met that need to where anything below 80 feet, we can now be able to show and show it instantaneously. So let's talk a little bit about the new features here. If you know cnHeat, you know that on my screen here, what's new is there is now a slider for signal strength, and there's a slider for SM height. And these are tied together. And so the way this works is, if you are interested to only see signal strength at, say, a neg 60 dBm, it will immediately filter to neg 60 dBm. And if you're only interested in seeing install heights at, say, let's say, 3 feet, it will then additionally filter to 3 feet. And there's 2 different views. There's a signal strength view, and then there's also the height view. And so let me kind of zoom in a little bit here, make it a little bit better, and I'm going to bring this back out. Perfect. And kind of show you what coverage looks like when we consider everything that might be installed up to 80 feet. And so we tried to do 2 different color schemes. We tried so a user would not get confused on which one they were looking at any given time. And yeah, so this is what we've come up with. To try to show you some examples, we have 4 different scenarios we want to walk you through. So first scenario is just the normal install. cnHeat from its conception was always envisioned as a pre-qualification tool. to be able to help customers know when they would and would not be able to connect, someone when they call in without ever having to roll a truck. So this is kind of an example of that. So customer calls in, CSR takes the address, types it into cnHeat. It takes us to that address. And so let me zoom in a little bit more so we can see this here. For those that aren't as familiar with cnHeat, I guess what I should say is that cnHeat uses a digital surface model. It's as if you took a fabric cloth and dropped it over everything. And so if that cloth, sits above a tree, it sits on top of a tree. When we talk about SM install heights, we're talking about above where that cloth sits. So when we say an install height of only, 2 feet, that's 2 feet above that tree. When the cloth falls on ground, it's 2 feet above the ground. When it falls on a building, it's 2 feet above that point on the building. And so the resolution that we're dealing with is high resolution. It's for a typical home, we have about 100 discrete elevation points for that given home. So we can tell the difference between the height at the peak of the roof to the height at the eave of the roof. And we can tell the difference between a 1-story home and a 2-story home, or one home and the neighbor's home. For every tree, we know the height of all the different kind of sections of the tree. We have multiple heights per tree. And so we're not taking just kind of blanket default heights and just kind of putting it in there. We're actually using real heights that were actually measured using LiDAR data, using LiDAR. So when we're talking about heights here, what we see from this home here is that absolutely they're covered, but they're covered in this case at 76 feet above, all these things, which isn't really that useful. So the first thing a CSR would do is they would take it down to something reasonable. They would take it down to say 3 feet. At 3 feet, we see that sure enough, right at the peak of the roof, right here in the center, and we can click there and it shows us we're 1.68 miles from the tower. We could put a tripod, and at 3 feet, we could actually connect there. And so that's what this is used for. They could also, try to slide it down, try to see, how low they could possibly go. But an installer is going to know the exact place on the roof where they should install, and also within a foot or two how high they should install. And if they wanted to go higher, obviously they can go higher, but at least a minimum install height to be able to see the tower. So this is kind of the standard kind of use case. Let's go to the other end of the spectrum. Let's look at another one here.
So really, for my interpretation, Seth, on this house you're currently showing, really, if you wanted to do a low install of like 3 feet or less, there's only one spot on the roof. There's nowhere like on the back garage or that back building or anywhere in the yard. It's telling you the one spot where you can install at.
That's right. Yeah, and I guess the other option is if a customer, they were concerned about aesthetics of their house, and they said there's no way I'm going to install there, then we can start to, move up and be able to see what kind of mast, if we were going to mount a pole right beside the house. In this case, if we ended up putting a pole kind of right in this location, a 15-foot pole, this would accomplish the same thing. And so, it gives the customer, it gives the operator some options whenever dealing with customers. Customers don't always want to accept, the install the way that would absolutely work best. And so, yeah, to your point, mounting on the roof is the number one best lowest height, but if that's not acceptable, they could also, slide it and try to find a place where they could put a pole alongside of the house to be able to connect as well.
So what you've shown here is when the customer calls in, the customer service rep can say, we can install on the roof at 3 feet, or we can install next to your garage or in the backyard with a 15-foot pole, and they can have their choice then, the customer.
Right. Exactly right. Exactly right.
Okay.
And it's saving, the installer, they may, not always are installers the most experienced. Sometimes, installers leave a company, you have to hire someone new, or sometimes installers get promoted inside of a company, you have to hire someone new. This kind of levels the playing field for experienced installers versus inexperienced. It really supercharges those inexperienced installers by giving them the information that they need before we ever roll a truck. And so this is one of the things that we're really excited about. The other end of the spectrum, customer calls in and they live, let me make sure I have this expanded here. I'm just going to swing it all the way. They live on South Goddard Road and they say, we're interested in connectivity. Well, we can see, at 10 feet, the CSR could quickly see at 10 feet, there's no coverage. They could keep sliding this up further and further. But what we find out is, even with an 83-foot, in this case, install, we still don't see any kind of coverage. A customer like this, it looks like there's an old grain silo in the backyard. They might call up and they might say, we're desperate for connectivity. We even have a grain silo in the back. We're pretty sure you can see the tower. And with this tool here, we can say with confidence that even if you put an 80-foot pole on top of that grain silo, you still wouldn't be able to see the tower. So there is no way we can connect this customer, at least not from this one tower, not from this example. So this is a case where you would save your money and not roll a truck. And every time you do that, in general, I think operators understand where they do and don't have coverage. And so if you have towers that you've had for a long time, you've learned your lessons. You kind of understand when not to roll trucks like this. But anytime you expand your network, anytime you have a new tower, you start that learning process all over again. And you're going to have, 4, 5, 6, 7 failed installs before you start to figure all these things out. And what we're saying is, let cnHeat help you. Let it keep you from having to learn those lessons the hard way, where you're paying $50 for every failed install to understand, where you cannot, possibly meet these installs. So this is the other end of the spectrum, and cnHeat helps here as well. We have an interesting case. Let me take you to the next one. We call this one the impossible install. Customer calls in 117 Alden Lane. And one of the ideas behind this feature is that you could look at a property and you could find the best point on that property to install. So not just to help the CSR know where to install as far as like on a roof or how high they need to install, but for an entire property, where's the absolute best spot that we can install? And so this customer calls in our example here, and the CSR, the first thing they check maybe is, can we connect them at all? They take their slider, they take it to 10 feet. For this particular customer, this operator, that's the highest they're willing to go. And what we see is that nowhere on the roof is there any spot where a 10-foot mount would actually work. But whenever we slide it all the way up, we change the opacity, we start looking for kind of the hot spots. We start to see that there's this kind of strip right here, right by the fence. And so this is kind of an interesting.
Just to interrupt you, the hot spots are that you're saying by the fence, they're the colors that correspond with the slider below, right?
Yeah, right. So the hot spots, we're in the height view or the installation view right now. We can click back and forth, but in the installation view, the hot spots are relative to the heights. So if it's a hot spot, that means you can connect to it with a lower height. And if it's blue, if it's colder, then you would have to install higher. And so we're looking for kind of the lowest spot that we could reasonably install. And in this case, there's a spot by the fence here. What we find is that as we start sliding this down, we start looking at things that are reasonable. Okay, well, sure enough, we could put a 40-foot pole, maybe beside the house here on the corner and be able to connect. But it really kind of gets better than that. Even at a 25-foot pole, or I think it even, almost goes down to 20 feet. If we mounted a 20-foot pole right on the corner of this fence, we're able to see the tower. We're able to connect. And the reason why is it just happens that there are several driveways that line up along the path here where there are no trees that give us a clear view of the tower. You know, this is something that wouldn't be intuitive to even an experienced installer. You know, an experienced installer would probably climb on top of the roof. They would walk around. They would know exactly where the tower was. There would be no confusion there. They would know what to look for. But at 6 feet above, they wouldn't be able to see the tower. They may even take a pole up on top of the roof. They may take a 10-foot pole or maybe even a 15-foot pole. But what's interesting here is even with a 22-foot pole, we don't have any access to the tower from the roof line. It's only if they knew that they would go right to this corner of the fence to be able to see, you know, through the trees, would they actually be able to connect. So this is an install that even an experienced installer would probably miss. And yet with cnHeat, we're able to extract information that we wouldn't be able to otherwise. And then the last thing I want to show is I'm just going to zoom out here. One of the other benefits is as we slide this all the way up, we can start to see, you know, some of the underlying, really the underlying data. It's almost like an X-ray view here where we can start to see the crowns of trees. We can start to see buildings. You know, this is something that can help us additionally, where whenever a CSR is looking and they're looking at coverage, it becomes more obvious when they're looking at a tree. And some operators are willing to install above trees, which that's helpful, and some aren't. And to know when there's a tree and when it's a building and the coverage that they're looking at makes kind of a big difference, because not always does satellite imagery line up with the LiDAR data that we collect. Sometimes trees grow and they fall over, and there can be differences there. So those were the examples that I have. I'm going to pass it back over to Dan.
Oh, one thing I wanted to point out, and I said it already, but I just want to reiterate so folks know, is if you could go back, zoom out a little bit and click on the signal strength. Would you do that, Seth?
Yeah, I need a faster computer.
Yeah. Well, one of the things that you hear is, you see that this is a perfect shot, is the color. One of the things that folks asked us about was how do we handle the RSSI heat map. And you'll see here that the colors are changing in gradients. You know, it's going from orange to yellow, but you can see about every 1 dB where it changes. So you can get a really good idea now as to the signal strength that you'll generally get for your customers in advance, and then also for the entire area. So, I mean, I could see the tool being a nice tool when someone says they complain about service. You can go to your cnHeat map and they say my RSSI is this, and technical support could come in here and say, they're in this band of RSSI and it should be this, and it's easily seeable, and they can see maybe something's gone on that's causing that to be off. So a little benefit there also with the improvement with the slider for the heat map colors.
Yeah, Dan, and I'll add, we're going to try to squeeze this into this release, but we're going to change the distance tool. We're going to add an additional column. So whenever anyone's using the distance tool, it will show every tower that's within, I think it's 16 kilometers, but then it'll also show the receive level for each one of those towers. So very quickly, a CSR can see the receive level for each one of the towers and be able to determine, you know, which is the strongest and what they should expect.
So that's an interesting point. So when you go to a certain customer that's in between towers and you see the distance between the two in the RSSI, then you can quickly switch between which sites you're looking at to see the heat maps from each one individually. So
That's right.
You can play that way.
Exactly right. Yep.
That's all I really wanted to share also. So with that, I think that's our presentation. If anyone has any questions, we'd be glad to answer them, or if not, you can always contact Seth and myself at Cambium. My email address is daniel.sullivan@cambiumnetworks.com, and Seth's email is seth.poche, P-O-C-H-E, at cambiumnetworks.com, and we'd love to hear your input and anything we can do to help you with it. Olivia, are there any questions?
Hi, Dan. We have one question so far. One person asks, if I can provide 1 meter resolution data for Ontario, Canada, would this service become available?
Yeah, and we have provided 1 meter service. There is 1 meter LiDAR in lots of Canada, in Ontario, especially the southern and to the east. So all you have to do is contact, go to the website, and you can download the form and send it off to us, and we can look at for you. Or you can just simply contact Seth or myself and say, here's where we're at. Do you have it? And we can let you know right away whether you have coverage or not.
We have another question asking, is there a map published of the LiDAR data used by cnHeat?
No, there is not. Yes and no. So if you want to get a quick look of whether you might have coverage, there's a thing called the national map, and that's provided by USGS, and it's a quick way to see whether there's certain areas that have coverage. But the map is not complete, and there's oftentimes data that's not in it that's better than the national map has. So what I've been doing is I have a way to collect all the data from the different points, and I can accumulate the data to try to understand what's there. And then an answer to the previous question from Canada is obviously the national map doesn't cover that. It's for the United States only. And for Canada, there's a different map that they have. And what I found is that's not complete also. For example, we recently found data that covers much of Quebec, and it's not shown on their map either. So if you want to, contact us, and we'll get back to you to let you know, or you can go to the national map and look there too. But we'll help you if you want. It's not straightforward.
That's all I'm seeing for questions right now.
Okay, thanks so much, Olivia, and thanks, Seth, and we appreciate everyone who's attended the webinar.
Thank you, Dan and Seth. We'll have a recording of this presentation available on the Cambium Networks YouTube channel and our online Cambium Networks community. Thank you for joining, and have a good day.